Right, questions on maximum length, minimum length when you're rounding tend to crop up on the non-calculator paper. And again, it really helps to think clearly with the context of the question when you're working with these. So this first question, square tiles are manufactured. The length of each tile is 300 millimeters, correct to the nearest millimeter. Okay, so if you're measuring and you're rounding correct to the nearest millimeter, then as far as your measure is concerned, the one down from 300 is going to be a millimeter down from it, which is 299. So if you think we're going from 300, the next one is 299, and the next one above it would be 301. And what you're looking for as far as the least length and the greatest length is the measure between there, where you decide whether you're going to round down to 299 or round up to 300. And similarly, when you're going to round between down to 300 and up to 301. And hopefully you'll be happy that the dividing lines are going to be 299.5 there and 300.5 there. Okay, and these are in millimeters. So these are the two trigger points. 299.5 is the least length, and 300.5 we put that in as the greatest length. Now you accept that 300.5 would actually round up to 301, but as far as the limits that we're concerned, rather than have to write 300.49 recurring, that's the value that we put in there. Okay, so trip through that again. We're measuring correct to the nearest millimeter. So we're going to go up 1 millimeter, 2 millimeters, 3 millimeters, and so on. So by the time we measure something as 300 millimeters, either side of the 300 is going to be 299 millimeters one side and 301 millimeters the other side. The trigger that takes you from writing 299 rather than 300 is halfway between it, 299.5, and similarly the other side, what triggers you from writing down 300 or 301 is the midpoint between the two, which is that. Okay, part B. The distance between the two walls in a passageway is 302 centimeters, measured correct to the nearest centimeter. So now we're going from here, where we're talking about tiles and millimeters, we're now talking about the length of a passageway. Okay, distance, and we're talking about centimeters, and we're talking about 302 centimeters, and again this is measured to the nearest centimeter. So down 1 from 302 is going to be 301, and up is going to be 303. And the triggers are going to be 301.5, which will take you between those two centimeters, and 302.5 centimeters here. Okay, now what they're asking you to do here is get your head around this. The tiles are laid end to end between the walls. Explain, showing all your calculations and reasoning, why it is always possible to lay 10 tiles between the walls. Now what you're going to think of here is that the worst possible case, or the fewest number of tiles you're going to need, will be when the distance between the two walls is as small as possible and the width of each tile is as wide as possible. That would be the worst case scenario. Okay, so worst case will be shortest distance The shortest distance between the walls is going to be 301.5 centimeters. With largest width tiles. Okay, and the largest width tiles are 300.5 millimeters. Now, I can't compare those as they stand because this has got the units millimeters and this has got the units centimeters. So in order to change millimeters into centimeters, I have to divide by 10, and you need to know that. Okay, so if I divide that by 10, then that becomes 30.05 centimeters. So one tile has got a width of 35.05 centimeters. I've got 10 tiles, and if they're all maximum width and laid end to end, then I'd have 30.05 centimeters times the 10 tiles equals 300.5 centimeters. 300.5 centimeters is smaller than that minimum possible distance between the walls. The distance between the walls cannot be smaller than that. So even if you got the, or if every tile is its maximum distance, so its maximum possible width, you'll still have space. 300.5 is less than 301.5. So 10 tiles, all as large as possible, is less than the minimum possible width. Minimum possible distance between walls. So let's go through that again because it's quite tricky. First of all, we got the tiles. They're 300 millimeters measured to the nearest millimeter. So when you're measuring, you're going up in 1 millimeters. So the next millimeter down from 300 is 299. The next millimeter up from 300 is 301. The trigger, which takes you from one to the other, is halfway between, which is 299.5, and between 300 and up the next one is 300.5, and they're in millimeters. Then we've got a distance between two walls measured in centimeters. Again, it's measured to the nearest whole centimeter. So when we're going from 302, the one below it would be 301, the one above it would be 303, the triggers halfway between. And what we've got to work out is that if these tiles are laid end to end, what's the worst combination we can have to always be able to lay 10? Well, the worst combination is if every single tile is at its greatest width. So they're the biggest tiles that we're going to have, and that the distance that we measured is actually at its narrowest. Okay, and its narrowest for the distance is 301.5. You can only compare them when they're in the same units. So I've kept the distance between the walls in centimeters, and I've changed the width of the tile from millimeters to centimeters by dividing by 10. As it happens then, we've got 10 tiles, so we end up multiplying that value by 10, but now our total is in centimeters. So now I can compare the two. The narrowest the passage is going to be is 301.5. The widest 10 tiles is going to be is 300.5, which is less than it. So then you need to put a sentence in there explaining what that actually means. Okay, so it's quite a challenging thing to get your head around. Plus, you're not allowed to use a calculator. Let's take a look at another. So the context of this one is we've got mass that we're dealing with. It's 15 measured to the nearest kilogram. So again, what we're talking about is we're measuring 15 kilograms, or less than that would be 14 kilograms, or above it would be 16 kilograms. So the trigger is going to be 14.5 kilograms, which will determine whether you're going to write 14 or 15, and 15.5 kilograms will determine whether you're going to write 15 or 16. So the least and greatest possible values which will give us 15 are that which would round up, and this which would round down. And as with the other one, I know that that would round up, but we're not going to be able to work with 15.49 recurring, so it's acceptable to write it within that range. Find the greatest and least possible values of the mass of 100 blocks. So if we've got 100 blocks each weighing that, then we're going to have 14.5 times 100, and hopefully you're happy doing that without a calculator to get 1450, and similarly 15.5 times 100 will be 1550. So those are the size, the maximum size of the blocks. Sorry, the maximum mass and the minimum mass of 100 blocks. Okay, Denver wishes to be sure that he puts no more than 1,500 kilograms of blocks onto his lorry. Find the greatest number of blocks that Denver should put on his lorry to be sure that there's no more than that on it. Well, again, the worst case scenario here is that all of the blocks weigh the maximum amount. So if they all weigh the maximum, he's not going to be able to fit 100 on, okay, because that's going to take him over 1,500 by 50 kilograms. So let's try and reason this out. So if all blocks are max mass, then 100 will be 50 kilos too much, too heavy, yeah, because that's what the 100 would come to. That's all he can have. So he's got to lose 50 kilos of blocks. Okay, now one block is 15.5. So 2 blocks will be 31. 3 blocks would be adding another 15.5 onto that, which is 46.5. So that's still not enough. So we're going to have to take off 4 blocks. So 4 blocks less, fewer, i.e. no more than 96 blocks on lorry. Okay, that would have been really straightforward with a calculator, because you could just divide 1,500 by 15.5, but without a calculator it's a bit more work. But again, it's the same idea. You're dealing with the worst case scenario, which would be if every block was at its heaviest. And one more of this type of question to look at. This time we're dealing with volume, and this time, look, it's measured to the nearest 10 centimeters. So it isn't going to go down to 499 and up to 501. It's going to go in tens. So the one below that would be 490, the one above it would be 510, and your triggers are going to be 495 milliliters, sorry, centimeter cubed, and 505 centimeter cubed. Okay, so if it's rounding to 500 to the nearest 10, if it was 496, you'd write 500. If it was 494, you'd write 490. So the trigger between one and the other are the 5s, 495, 505. So that's your jug, and that's in centimeters cubed. Now, we're pouring water into a tank of volume 15.5 litres measured to the nearest 0.1 litre. So if it's 15.5 litres, if we're counting up in 0.1s, if it's not 15.5, the one below it that we would write would be 15.4, and the one above it that we'd write would be 15.6. And the trigger between that and that is going to be halfway between the two, which is 15.45 litres and 15.55 litres. Okay, so water is poured from the jug into a tank of volume 15.5 litres measured correct to the nearest litre. Explain to all your calculations why it's always possible to pour water from 30 full jugs into the tank without overflowing. Okay, so again, the worst case scenario would be the smallest tank being filled by largest jugs. Okay, so that's the worst case. Smallest possible tank. I mean, the smallest possible tank has got a capacity of 15.45 litres, being filled by 30 big jugs, biggest possible. So if we've got 505 times 30, then what we've got here is 5 3s are 15, 0 3s 0, add 1, and then 15. Okay, so, and then add the 0. So we're dealing with that number, 15,150 cubic centimeters in those 30 jugs. Now, to change cubic centimeters to liters, again, it's a fact you need to know that there are 1,000 cubic centimeters in 1 liter. Okay, 1,000 cm cubed is 1 litre. So we divide that by 1,000, and if we divide that by 1,000, hopefully you're happy that that is 15.15 litres. The smallest tank is 15.45. Okay, so 30 of the largest jugs, 30 times large jug, is less than smallest tank. 30 times a large jug is 15.15, which is less than the smallest tank, which is 15.45. So they'll always fit Okay, so you've got to be quite careful with your logic and the way that you're working with questions like that. Quite tricky.